Now we are going to start with the properties of borax. So the first thing is that when we look at it, when we separate the crystals, then how they look like. So it is white in color, that means it is white, crystalline, solid. This is how borax looks like. Second, if we talk about its solubility part, then we will see that it is less soluble in cold water, but it is more soluble in hot water. So that means solubility is more in the hot and less in the cold water. Third, if we talk about the nature of borax, then borax is alkaline in nature. How I am going to prove that? See, I am going to take borax, which is Na2B4O7, and I am going to add borax into water. And when I do this, what do I get? I get sodium hydroxide, and along with that I get a weak acid of boron, that is H2B4O7. Then as you can see, this is a strong base and it is a weak acid, right? So what will be the nature? The nature, we know that nature comes from this, that whether the acid form is a strong one or a base form is a strong one. So you have seen that the base is comparatively stronger, so that means the solution is alkaline in nature. That means it is its nature, chemical nature is alkaline. Now you know that this H2B4O7 when added to water, then it get converted into a boric acid, that is again a weak acid, that is a boric acid. So either what you can do is, you can write the direct equation where you are going to add Na2B4O7 with water and just write NaOH plus H3BO3. But if you need to show it in detail and really you need to learn it in a proper manner, then please learn this thing, that when we react we get a very weak acid, which is very weak acid in comparison to boric acid, which is H2B4O7, and then this H2B4O7 when added to water forms boric acid. So if somebody asks you about the nature of boric acid, how you are going to show that? Just add into a water, and as a result you have these products. Just compare their strength, that which is strong, which is weak, and if the base is strong, obviously the substance is alkaline. This is what you get to see here, that we have a strong base and a weak acid. So obviously it shows that borax is alkaline in nature. Next property we have is, we are going to see the effect of heat on borax. So what happened? Suppose we have this borax Na2B4O7.10H2O, right? So when we heat it, so in the first step initially what happens? This water of crystallization gets separated out. So what do we get? We get anhydrous borax, that is Na2B4O7, and these 10 water molecules get separated. Then we can actually heat it more. So we have this Na2B4O7 again, anhydrous borax. We heat it more, and when we heat it more, what do we get? We get sodium metaborate, and along with that you get boric anhydride. We get sodium metaborate and boric anhydride. I am just going to write the names because these names are very important. This is sodium metaborate, right, and this is boric anhydride, right? And you know that the mixture of two, like when we heat it, this NaBO2 and B2O3, they actually appear to be a transparent like thing, and they are called as transparent glassy bead. And you know that this glassy bead actually serves very important purpose. Where this glassy bead is actually used, this bead, that is the glassy bead, which is also called as borax bead, it is used in the qualitative analysis, that whenever you need to detect certain cations, then we can actually use this borax bead, or you can say a transparent glassy bead, in order to detect the presence of the ion. So how, which colored ions can be detected by this glassy bead? It is nickel, cobalt, chromium, copper, and many more actually can be used. So how this borax bead test is carried out? Just look at the board, because this is very most important question of this topic, that is the borax. So when we take certain colored salt which contain these ions, either of these ions. Let's say that we have taken a salt which contain a cobalt ion. that is the cobalt cation. Let's say our salt is cobalt sulfate. Let's say our salt is cobalt sulfate. Then what actually happened? We heat it first, right? So when you heat it, it decomposes to form its oxide. It decomposes to form its respective oxide. Then when you take this colored salt ions and you add a glassy bead, the first thing is that, and you heat it also. So the first thing what you get is they decompose into their metal oxide and respective oxides are further formed, but we are actually concerned with the cation oxides because we are carrying out the qualitative analysis for that particular cation. So as we were doing it for cobalt, so we are concerned with the cobalt oxide, right? Then this cobalt oxide react with another component of the glassy bead, that is boric anhydride, and when it does, it forms its respective metaborate, and these metaborates actually are colored. Like in case of cobalt, we took an example of cobalt. Here the color of cobalt metaborate is blue. Likewise, if you take any nickel salt, nickel colored salt, then what happens? It will form nickel oxide, and further this nickel oxide when react with the boric anhydride of glassy bead, it is going to form its metaborate, that is nickel metaborate, which is particularly NiBO2 whole twice. And you know that what is the color for this metaborate? It is actually brown in color, right? Likewise, if you take a copper salt, chromium salt, you will get a chromic oxide, and it will react with the boric anhydride, and it is again going to form its respective metaborate, which is CrBO2 whole thrice. And what is the color? This is green. So likewise, you can actually conduct this test for different cations, and I have mentioned few of the colors of the metaborate of few cations. Like for nickel it is brown, cobalt you have already done, it is blue. For chromium it is green, manganese it is pink, violet. That I am talking about all the metaborates of the cations, these. Pink, violet. For copper it is dark blue, right? So we see that this is for cobalt, and for copper it is actually colorless. So that means we can actually conduct this borax bead test, and which contain a glassy bead of constituent NaBO2 and B2O3, and these can actually be used in order to in the qualitative analysis in order to detect the presence of particular cation. And how we come to know that this particular cation is present, as they form their respective metaborates which are colored. So this is a borax bead test, but still we have few more properties also of borax, so just look at the board carefully.